Our next proof has a given of 4 times m minus n equals negative 12 when n equals 2, and we are trying to prove that negative 1 is equal to m. So first thing you always start with is your given. So let's copy it down exactly as we see it. We're not going to change a single thing. Oops. Sometimes my touchscreen gets really angry at me, like right now. When n equals 2. Much better. Okay, that's our given. So I know that n is equal to 2. I can go plug the 2 in for n. So that is called substitution. I'm going to go substitute the 2 in place of n. So that would give me 4 times m minus 2 equals negative 12. I didn't change a single thing. The only thing I changed was I plugged the 2 in for n. Substitution property is my justification. I just went and plugged the 2 in place. That's called substitution. Okay, now if I was going to solve for m, which is what I'm trying to do, I would take the 4 and distribute it to get 4m minus 8 equals negative 12. So that reason is the distributive property. The next thing I would do is I want to get that negative 8 over to the other side. So I would add 8 to both sides, which would give me 4m equals negative 12 plus 8 is negative 4. So because I added 8 to both sides of the equation, that's the addition property. And then I want to get the m all by itself, and so I would divide off the 4. So I divide by 4 on both sides. So 4m divided by 4 is m. Whoa. The struggle. The struggle is so real. M equals, and then negative 4 divided by 4 is negative 1. I divided by 4 on both sides, so that's the division property. So you might be thinking, okay, I'm done with my proof. Not exactly. Always go check the proof statement that it gives you. The last step of your proof must match the proof statement. Exactly. It must be identical. So our last statement says m equals negative 1. The proof statement says negative 1 equals m. Those aren't the same thing. So that means we're not done with this proof. We have to add one more step. I'm going to switch it around so it says negative 1 equals m. And when the left side of my equation becomes the right side, and when the right side becomes the left side, that is called the symmetric property. When you're switching the left side and the right side, the symmetric property. And we're done. Now my proof statement is my last statement of my proof. One more thing I want to talk about. So I'm taking the 4 and I'm multiplying the m by the 4 and the negative 2 by 4 in step 2. And that's called the distributive property. Sometimes people want to say, well, Ms. Briscoe, you're multiplying. You're multiplying 4 times n is 4m, 4 times negative 2 is negative 8. Why is that not the multiplication property? Remember, the multiplication property is when you multiply the left side and the right side by the same number. Notice, negative 12 was the right side of my equation in step 2, and negative 12 was the right side of my equation in step 3. I did not multiply the right side of my equation by anything. I didn't change the right side of my equation. So I can only use the multiplication property when I'm multiplying both sides of my equation by a number when I'm doing the distributed property, I'm only affecting the left side of this equation. So I'm not multiplying the left and the right side, I'm only distributing. So that's the difference. Notice my right side of my equation didn't change, so it can't be multiplication property. Multiplication property is when you're multiplying both sides of your equation.